have the Inspire faceplates, or the Inspire calculator, so you don't really have all of the app stuff on there like some of the other ones were. Yes, sir.
I forgot to turn in my second.
Bless you. When we come up to that Quizam thingy this Friday, then I'll still give you guys that sheet of all the stuff, or I might just write them up on the board, save paper or something like that, and go from there. Hi.
I couldn't help eavesdropping, because it's what I do.
That's right.
Were you saying the Inspire people?
When we switched to the Inspire plates, the 84 plates, a lot of them didn't have that app built in for the Conic app, whereas the 84s had the app already preloaded on most, because I put it on those before. So it takes forever to load those, and I'd have to do 30 some of them. I mean, I can do it, but it's just as easy to take a
I think if
screenshot.
Mr. Murphy really cared about you guys, he would do it. No, honestly.
Hey, you know what we watched last night?
Monday Night Football.
We tried that American Horror Story thing. You watched that?
I like that show.
It's really good. Yeah. I've never seen it before, but it's freaked the bejesus out of me.
Okay.
I watched that. We had heard it was pretty good, so we watched it last night. If you didn't have a fear of clowns going into it, you do now.
I was told to watch that, so I tried it out over the weekend, and I liked it.
Yeah, it's pretty crazy. Anywho, well, we're looking at the hyperbola shift here, guys. Same thing is happening. The difference between the hyperbola and the ellipse is very obvious. Oops. Is that it's a subtraction between the two fractions, and the a squared always stays put. A squared and b squared always stay put. A squared is just the first value, b squared is the second value. It does not mean that one of them is bigger than the other. That's out the window. That only is holds true for the ellipses. Okay? What comes first is either the x squared or the y squared to tell you what direction you're going. Excuse me. So if that x squared term comes first, it means it's going left and right. If the y squared term goes first, it means it's going up and down. Okay? Your center is just going to be located at the h and k, just like it was for everything else that we've done before. In order to set these things through, that a squared term, the b squareds, and the c squareds, the relationship with those was a squared plus b squared, because it's that c squared. That a value is still our distance from the center to the vertex. The b is still the distance from that center to what we call the co-vertex. We don't know what it's called. And the c value is the distance from the center to the focus. That doesn't change. Remember that your curves always, the vertex always opens to your focus. That's why our focus is further away than our vertex. That's why they're opening outward. We will get to the asymptotes in these as well, but we'll work with them again when we do that little rectangular box. It'll be very easy just to walk it and go through it. So what I want to kind of do here is just jump right into a problem, okay? And walk you through how this stuff works. Excuse me. And doing it differently this time. We're going to go to the equation first this time around. We're going to do the equation first this time. We might as well, for the last one that we have, we might as well switch it up a little bit. We'll go to the right of the equation first, then we'll do the graphing. Okay? So we have a hyperbola with foci at 5, 2, 5, negative 6. And we have vertices at 5, 0, and 5, negative 4. What do you think the first thing I'm going to do is? Graph it. All right, let's plot it. See what it looks like. So we're going to graph and plot it to get a good idea so we know what direction it's moving. 5, 2. 5, negative 6. And then vertices at 5, 0, and 5, negative 4. So I know it's got to be doing this. Is everybody okay with that? I know it's got to be opening up and down?
Yeah.
Okay. The reason why I know this is opening up and down is because, remember, your vertex always looks at the focus. Okay. So which come first then? Would it be x squared or y squared?
Y squared.
Good. So we know this has got to be a y squared hyperbola. And just like we did before when we did the shifted ellipses and stuff, bless you. Bless you. What happens at the midpoint of the vertices? What happens at the midpoint of the focus? The center, yeah. So I know the center is going to occur at the midpoint of these guys. Well, we know the center's got to be at an x value of 5. Everybody okay with that? So I know that my h value is 5. So all we do is find the midpoint. Well, what's 0 plus negative 4?
Negative 4.
What's half of it?
Negative 2.
So it's at 5, negative 2. There's my center. There's h and k. Everybody okay with that? Yeah?
Yeah.
Oh, okay. Now, let's go through the distances. Going from the center to the vertex is how far? 2. So A is 2. Everybody okay with that? Going from A to the C value is my focus. How far is that? 4.
4.
So A squared is 4, C squared is 16. I just squared that right there. A was 2, C is 4, A squared is 4, C squared is 16. What's B squared then? Good. Do I have enough information now to write the equation?
Yes.
Yep. Fill in the blanks. I get y plus 2 quantity squared over 4 minus x minus 5 quantity squared over 12 equals 1. I'll do a little change of pace and write the equation first. Not scary, is it?
No.
Not at all. Hopefully. All right. All those values at A, B's, and C's that we've been beating you over the head with, if I can say it correctly, it's where it all comes back. Okay? So let's graph. Yay. Questions on writing the equation at all? Did I have to give my asymptotes for this one at all? Did I have to worry about plotting out covertices or anything? No, just said write the equation. We did. So, let's graph it. No more moods. Yeah. It's your birthday. Is it your birthday?
It is.
Well, happy birthday. You're welcome. If you want to sing, you can sing.
No, I am one of everyone.
Man, you're a great singer.
No.
I'm a good singer.
I'm a good dancer.
No, you're not. Please stay in school. Please stay in school so we don't have to worry about you trying to live your life as a singer. Gundy's going to sing? Oh, that's...
Oh, can we please?
That's going to be awesome.
Yes.
What hour is that so I can walk by?
7, 8.
I'll just bring my whole class with me.
I hope we can.
There's a lot of people
All right.
that have 7.
When I'm looking at this right off the bat, you guys have all written this down now. Do you know which direction this is going to open? Why is it going to open up and down? Because y squared comes first. Good. So remember, make a little rough sketch so you don't screw it up later. Because you never do that.
I do it. Negative 1.
I'm also going to do this. I'm hoping that you guys did that right away also.
Yes.
Good. That means you know what your a squared term is. What's a squared?
1.
Is 1 b squared? So what's c squared going to be? 5. Very good. And I can just leave it like that for right now. Everybody okay with that? What's my h and k?
Negative 1, negative 1.
Good. In this case, you got lucky because they're both at negative 1. Be careful. A lot of times when you have y squared terms coming first, you guys will get in the habit of accidentally saying that the first one is h, the second one is k. That's just how your brains work. Just remember to read it carefully to do that. Okay? So you know you're going to start at negative 1, negative 1. A squared is 1, so therefore A is plus or minus 1. B is plus or minus 2. And C will be plus or minus square root of 5. Not bad? All right, let's plot. Negative 1, negative 1. The distance from the center to the vertex is the value of A. So I go up 1, and I go down 1. So when I start writing a tally here, our vertices are negative 1, 0, negative 1, negative 2. Okay. Co-vertices, I have to go left and right in this case. Excuse me. I go left and right 2. So let's see, negative 3 and negative 1. 1, negative 1. Is everybody okay with that? Draw a rectangular box. Now we know we have to put our asymptotes in. All right. Now this is where you're going to ask, what about the slopes? Right, doesn't he? Now if I look at this, if I'm just walk the edges of that rectangular box, all I had to do was go up. What, we went up 1, right 2. So up 1, right 2, so the slope is 1/2. So I know my slopes of my asymptotes will be plus or minus 1/2. Okay. Right, okay. You can think of it that way, but you just walk with that little rectangular box, you'll never get it wrong. You're right, because you can't go with the B's and A's, but I don't, because I always forget it, which one's which. So it's easier for me just to walk it real quick. That's all. Right. Now it's just a matter of applying my focus. My vertex has to look at it. I can't add root 5 to something, so how do I write out my ordered pairs? 0 over 5. So it's 1, so it's 2-ish, it's about here. So we have foci at negative 1 plus root 5, comma, negative 1, and negative 1 minus root 5, comma. Oh, I have them backwards somewhere. Sorry.
Hello, Mr. Murphy.
Bonjour.
Yeah.
I do. Did you want her?
I don't know. What pass wants her?
I don't know. It's worthy.
Oh.
You're right. She's awesome. Well, no, I don't mean that you're not awesome. I'm sorry. That came out wrong. Anyway, sorry, I put them on the wrong side. Okay. Makes sense? You see how everything falls into place just like you guys did last time? Like with the ellipses and everything else. It's just a matter of being able to identify what goes where. A's center, vertex to center. B's vertex to that co-vertex, or it's not vertex, it's center to the co-vertex. C is to the foci. Very, very, very straightforward. Okay? Yay. So you guys do this one. Take a minute, do this one. Yeah. The way I got the slope here is all I'm doing is you can do the B over A's, you can memorize all that because that's not on those formula things. But if you just remember that in this box, I went up 1, 2, 3, and I went to the right 1, 2, 3, 4, 5. I went up, and over 3/5. You can do it that way. I say that way is the easiest way to find the slopes because you're creating that rectangle anyway. It's just as fast. And then instead of trying to memorize out it's B over A or is it A over B? Okay. Does that make sense? Yeah. Cool. So what's the last scary thing that you haven't seen yet? The last mean thing of this then is the style when you have to worry about the completing of the square. Now, at this point in time, you guys have gotten pretty good at completing the square, albeit you still make a silly mistake here or there. But for the most part, you're pretty solid at this. When you're completing the square, when you have a hyperbola, there is one thing you will screw up. You've got to be very careful with this. First thing I'm going to do here, just like we've done in the past, is rearrange everything so you have your x squareds and your y squareds together. Everybody okay with that?
Yeah.
Right off the bat, you see how we've got a negative 9x squared?
Yeah.
I'm going to start the problem with the y squared term first then, okay? When I go to group my things together, because the order in which I'm adding stuff doesn't matter, does it? So it shouldn't matter the way I group them. So I'm going to group the y squareds first, and that's kind of the trick here when you have a negative value. Take the y squared terms first, or the y values, then put the negative 9x squared with the 54x, send the 161 over. Are we okay with that? Now comes the first step when you're doing the completing the square. Can I complete the square when my leading term coefficient is not equal to 1? No, so what do? Take out the 16. So I factor out the 16 in this first group, and I get y squared plus 4y blank. What do I take out in the second group? Negative 9. Very good. You got to take out the negative 9. So here's where you, it's supposed to be 54. This is where you guys are going to screw up. Notice I took out a negative value. What's positive 54 divided by negative 9? Negative 6. You guys will miss that sign over and over and over again. Oh, these are x's, sorry. So, on the other side, I have a 161. What do I have to put in then?
4.
Plus 16 times something, and then I have to do a minus 9 times something. Okay? That's where you guys will mess up. Be very careful when you have these negative values. You've got to be very cautious here to here. Okay? Watch those signs. So what's half of 4? 2. What's 2 squared? 4. So I'm going to add 4 to both sides. So this becomes 16y plus 2 quantity squared minus 9 times. What's half of negative 6? What's negative 3 squared? 9. So I'm going to add 9 to both sides. So I have 9 times x minus 3 quantity squared equals, if I'm not mistaken, I think you get 144 over there. And lo and behold, it's nice when they keep giving you values that wind up being divisible by one another. What's that? It's nice, isn't it? Okay. So now what do I do? There you go. It's y plus 2 quantity squared over 9 minus x minus 3 quantity squared over 16. So, what direction is this going?
Up and down.
Up and down. Very good. It's up and down. It's got to go up and down because the y squared term is first. What's your h and k?
Oh, no.
3, negative
See what you just
2.
did? What did I tell you 20 minutes ago? You're going to screw that up. Don't do that again.
Lost.
So your H and K is at 3, negative 2. Seriously, guys, be very, very careful when you have y squared or hyperbolas. Make sure you take a second to identify which one's the H and which one's the K. It is such a common mistake that people do. Don't do that. That means that your A squared value is 9, B squared is 16. What's C squared then?
25.
25. Boy, this is going to be a really easy one to graph, isn't it?
Wow.
Wait, we have to graph it.
Well, we always do. It doesn't hurt to practice it, does it?
Oh, that's so much work in such a.
Oh, wow.
How about we watch it graph this one? How about if we do it?
Oh, man. I know my vertex is distance from A, so A is 3. B is 4. We went up 3 over 4, so our slope will be plus minus 3/4. Focus. We're going up and down, so the distance for that is 5. And I'm sure you could probably list out all those points. Like I said, the hyperbola, it's not that it's extraordinarily difficult to work with. It's just that one subtle tweak with the negative in the middle is where you guys will tend to make your mistake. Okay? That's usually the only spot you're going to screw up. The A's, the B's, and all that other stuff kind of still hold true. Like I said, I'm going to give you a few of these to work on tonight. I might as well give it to you now. Tomorrow we'll do the systems. You guys have done systems of equations in the past. 2 equations, 2 variables. Well, we're going to do 2 equations, 2 variables, maybe even 3 equations, 3 variables with x squared and y squared and things like that as well. So I'll try not to make it too difficult because some of those get a little nutty and don't really worry about that much of it. So do those, please.
Sweet.
Okay. It's all hyperbola work. It's all hyperbola work. It's still, I forgot to write that out. It's still section 10.6. Again. 10.6 again.
Just in review, would you mind putting a couple of those on the?
No, I'll move on. No problem. Just let everybody write that down. I will. I'm going to put it up here in a second. Everybody get that written down up front? I can pull it up? You know, they say handwriting's the first to go as you get older. Right, it's like, I'm joking, making a joke. They're all the same. Yeah. Not as